right, so worksheet 8A is in your homework check. Let's get as much of this done as we can. And remember, that's not the real time, so you guys warn me when it's time. All right, so the enrollment at a Texas State University is currently 35,000. And then each year, the school will graduate 25% of its students. So they're taking away 25%, but then they're bringing in a flat number of 6,500. And they want to know the enrollment 8 years from now. So our first decision when we're doing these applications is to figure out what type of approach to take. Your choices are directly arithmetic, directly geometric, or sometimes recursion is the way to go. And this one, you guys were discussing with me that because there's a multiplication factor, also an addition factor, it's kind of like a combo of the two formulas, so we're just going to work with recursion, we decided. So let's talk about how this formula works. So the first term is what it currently is. So let's call that the 35,000. Now, if I was going to set up a formula for every year after that, let's first talk about this removing 25% of the kids thing. So you would take your previous year, remember how we write that for recursion? That's the A sub n minus 1, good. And then if you're going to graduate 25%, that means you're keeping 75%, right? So let's multiply that by 0.75. And then you're also going to get a flat gain of 6,500, so plus 6,500. And then we have to figure out 8 years from now. So if I was you, maybe this would be a good moment to use my calculator. Do you remember your calculator in sequence mode can do recursion? So it won't be the sum of the sequence stuff, none of that. I'm talking like the table usage. So grab your calculator. Make sure it's in sequence mode. And when you go to y equals and you're in sequence mode, the minimum n just keep as 1. But for the programming of the formula itself, I'm going to go 0.75 times, and then your calculator uses u instead of a sub n minus 1. So the u is found right above the 7 key. So second, 7. And then they don't do subscripts here. You just put parentheses n minus 1. So that's the previous term thing. And then we're supposed to add 6,500. Now, because it's recursive, you do have to set up this guy, the u sub n. So that means first term. So the first term, remember, was 35,000. And then if you go to your table, there's year 1, and they want 8 years. So, oh, but it says, read carefully, 8 years from now. So remember, we started at year 1, so you need to go to the ninth term. So down here, 9th term, 26,901 is their enrollment in year 9. I'll write some notes to people who are just looking at their slides. They're going to look at table, and they found a sub 9. And it was what? 26,901? Cool beans. All right. So this next one, let's read through. Business makes $10,000 profit during the first year, and then the profit increases by $7,500 each subsequent year. So what kind of a relationship is it if you just add $7,500 year to year to year? Is that arithmetic, geometric, or some sort of recursion? Yeah, it's going to be arithmetic, which is the easiest way to go. So you could call it recursion. But since they want the total at some point, I'm going to want to use my sum of the sequence business, so we'll get to that. All right, so let's write our formula, guys. The arithmetic formula starts with the original profit. So original term is 10,000. And then it's going to increase 7,500. And then times n minus 1. Because you wouldn't be increasing your profit right away. So then they want to know the profit in the 10th year. So I'm going to need you to find the 10th term, which you could just manually plug in a 10. So 10,000, excuse me. Plus 7,500, and then you can say times 9. That works for me. So I'm getting 77,500. Can I get a confirmation on that? Okay. And then it says, what will be the total profit? And I think the rest of it got cut off, but it meant for the rest of the 10 years. So for the total profit, let's do our sum of the sequence. So you type in your formula, which was the 10,000 plus 7,500 and minus 1. What did I screw up? Oh, I just have an extra 0 because I'm silly. Yeah, that's not how numbers work, huh? Here we go. Whoops. Oh, Bruza. Alright, there we go, times n. So whatever variable mode you're in, your variable goes next. And then we want the first 10 years, so 1 to 10. Hey, thank you. This should be a pretty intense number because you're adding up all 10 years. So I got 437,500. Let's see if I can do my digits properly this time. This is where you guys are going to tell me, like, that's wrong. No, is it right? Oh, good. Very cool. All right, next one. This one's a little confusing. It's that lecture hall question with, like, how many seats are in each row. But this one's extra confusing because not all the rows are the same. In fact, the last few rows have the exact same number. So I had to kind of map this question out before I screwed it up. 6 seats in the first row, 8 seats in the second row, 10 seats in the third row, and so on through row 12. So the first row, and I'm actually only going to go to the 11th row, there's this weird sequence pattern happening. And then once you get to the 12th row through the 20th row, it no longer keeps gaining seats because apparently their theater's only so big. So all of the rows here are going to be the same size. So I think what we should do is figure out first how many seats are in the 12th row. And then just understand that all of these rows have that same number of seats. And then we'll go back and figure out how many seats are up here from 1 to 11. Because they want to know total seats. So you can't just do sum of the sequence for all 20 rows because those last few rows are not. They're not graduating. All right, so real quick, we need to write up a formula here. The formula itself started with 6 seats. And then what was the pattern? This is arithmetic, right? It was adding 2 seats every time. So you're adding 2 seats times n minus 1. So if you needed to go find me the 12th row, can someone type that in for me and tell me how many seats are in that 12th row and subsequently every other row after it? I think I got 28. Can I get a confirmation on that? Okay. So all of these rows have 28 seats in them. How many rows are there between 12 and 20? Be careful. You think? It's not 8, is it? Isn't it 9? Because like literally if you count like 12, 13, 14, 15, 16, 17, 18, 19, 20. So that extra row, you know. All right, so we have 28 seats times 9 rows. I bet you can figure that out. Is that 252? Okay. But now I want you to talk to me about how many seats were up here. This part, you can totally do a sum of the sequence. So I would like you guys to finish up this question on your own. Once you do the sum of the sequence for the 1st through the 11th row, you're going to get an answer here. And you got this answer here, and you need to add these together. Okay? Oh boy. All right, this next question is going to boggle your mind a little bit. So for the whole month of March, so first of all, let's get around that one. How many days are in the month of March? You have a trick on your knuckles? What is that trick? It's something else? Generally 30, unless it's the weird February month, which no one understands. Okay. Wow. I didn't know that. Because I had to learn the old 30 days has September, April, June, and November. All the rest have 31 except February, which is weird. So there's more to that rhyme, but I don't remember it. I just remember it's weird. Is this what they're teaching you these days? Yeah, right, Tara? I don't know this either.
I learned this in my first grade.
Just on the end of your knuckle?
Yeah. So it's January, February, March, April, May,
Wow.
So the top nickel is 31. And then that is so cool.
I don't know. I really kind of like my rhyme from the 90s. 80s? 90s? 80s. 30 days has September, April, June, and November. All the rest have 31 except February, which has 28 and sometimes 29. it's got a week ending, let's be honest. All right. You know what?
Yeah.
I'll give you that.
Well, I'm sorry. I didn't write it. All right. So anyways, March, you guys told me, has how many days? What was the end of that story? 31 days. All right, cool. And you are going to get paid 1 cent on March 1st. So first of all, how do you write 1 cent? I know. You already did this? Oh, man. All right, so 1 cent. And then the next day you earn 2 cents. And it's not that they're adding a cent each day. They're doubling the amount of money that somebody gives you each day. Whoever this person is, you should thank them because this answer is going to freak you out, man. All right, so you're going to have this pattern happen. What kind of a pattern are we looking at when your money doubles every day? Is this arithmetic or geometric? It's geometric. Oops, it's geometrics. And that's where your R is going to be a 2 because it's doubling. So if I wanted to write a formula, you start with 1 cent, and then you're doubling it to the n minus 1 power. So how much money will you have at the end of the month? They're going to want you to total this. So if I was you, you could, remember how yesterday we learned there is a sum of the geometric sequence formula? You can use that one. I'm just going to use sum of the sequence, and yeah, that's the right face to make because I thought I had it wrong too. I had to go like double check my key. I want you to sum the sequence here, guys, and you're going to get a big old number. And I don't know who's giving you this money, but good on them. So sum of the sequence for your pattern. Remember to use parentheses around the n minus 1 exponent because your calculator is not going to do it in the exponent unless you do that. And then n, comma, 1, comma, 31. And then be amazed, children. It is a lot of money. I probably put my commas in the wrong spot again. Is it like 21 million or something? Yeah, it's like 21 million something. Yeah. Wow. So don't promise anybody that. Like, I will double your money every day for the month of March. No. All right. This one, we are constructing a monument by laying out bricks. The last row of 60 bricks. Okay. Oh, the first row is 60 bricks. The second row is 2 fewer bricks. And then they center them and they make this beautiful, like, pyramid shape. Third row, so on and so on. The top row contains 10 bricks. This is kind of a weird backwards question. First of all, can you guys tell me the relationship that we're working with if they just keep taking away 2 bricks each time? Is that arithmetic or geometric? It's arithmetic. And the common difference is that you're taking away 2 bricks, so it's a negative 2. So you started with 60 bricks. And you're taking away 2 bricks at a time. That's your general formula. But this last clue is a weird one. It says your last row contains 10 bricks. So I'm going to use that as like a solution clue. And I'm going to try to figure out what n is. Because that's, I think, the last row. And I need to know that. So good start would be to subtract the, 60. So you have negative 50 equals negative 2. I wouldn't distribute the negative 2 because I would just divide it by negative 2 right here. So you're going to end up with 27 bricks, I think. Or it's 27 rows, excuse me. So that's how many rows are going out. Am I doing that right? No, I didn't do that right because that's 25. I keep doing this thing where like I'm pre-solving and forgetting I'm pre-solving. I'm an idiot. Forget it. That's 25. You guys are really polite about my stupidity today. Thank you. Giving me a lot of grace, children. Okay, so there's 26 rows of this brick stuff happening. So the question is, how many total bricks are in the monument? So this is another good sum of the sequence, and you're going to go out to 26 rows. So if you would prefer to use the summation formula that we learned a couple days ago for arithmetic summing, you go right ahead. I don't like those formulas. I like to sum the sequence. And I got 910. So if you did get 910, it could be my problem. Is it not 910? You're giving me a face that tells me you didn't get 910. You didn't get 910? Oh, you did. Okay. I was like, if I'm the only one who got 910, then we're gonna have problems because that means I'm wrong. Okay. And then there's one more. Tuition at a university is $3,000 per year, and it's going to increase a flat $150 per year every year forever. So you're going to spend I love this question because this isn't even how college works. They're like, oh, 4 years in your undergrad and 3 years in law school. Grad school's way more expensive than undergrad, so nice try. But let's pretend we live in a magical world where everything costs the same. How many years are you in school? Adding there, guys. 4 plus 3 plus 5. That's 12, yeah. So you're going to need to add up. So you're going to need to sum the sequence. I'm going to leave that one for you to do, but just kind of to make sure you're going in the right direction. What kind of a sequence is it if you're adding a flat 150 every year? That's arithmetic. So start with the tuition and then add 150. This is a very cheap college. You should go there. Your law school costs like $4,000 a year. Yeah, cool. That's not a thing. These are like maybe a credit hour. I don't know. This is a lie, this question. This next one we're talking about, sorry. All right, so there's your homework. Finish up that question. So we're just peeking at the post-test review packet. Oh, it's that's frozen. I am recording, you just don't know it. All right, so day 1 starts right here. And we were very, very, very transparent for you. That's day 1. Very transparent for you guys. Like, we're not trying to trick you. We're not doing that thing that teachers do sometimes where they make the reviews like doubly difficult. No, this is exactly what it looks like. Okay, in order even. You do have those same formula sheets you had back when we were doing the trig stuff. So you'll be getting, some trig formulas here. Like that. It'll look exactly like that, in fact. So this is the standard position. Sketch it, make a triangle, make sure you're in the right quadrant question. Find the exact value for the cotangent. You get a unit circle, so as long as you remember how to find cotangent and you know how to simplify and rationalize, you should be good. There's your unit circle, buddy. He's on a formula sheet. Knowing that the cosine's positive but the sine is negative, you have to make sure you draw this in the proper quadrant, and then you go make a triangle. I feel like with all of the trig reoccurrence that we've had this semester, while maybe this question didn't go splendid for you like the first time we saw it, should be going a little better for you now at this point because you guys are more familiar with how trig in the coordinate plane works. Solving a trig equation. Am I looking at the right packet? Okay. So graphing, this is still day 1. Modeling, which kind of goes with graphing, still day 1. Talking about inverse trig functions, still day 1. And then this is the start of day 2. So let me look ahead real quick. These are all formula sheet stuff. Sum and difference formulas, knowing how to expand that out. Expanding it out with the triangles. Some of these questions should look really familiar because we literally did them on the test. So maybe look back at your old summatives, make sure whatever mistakes you were making that time you don't make again. Then we are going to get the harder equation solving ones where you might have to like do some factoring, make sure nothing's extraneous. So that's the end of the trig. So trig is kind of split on day 1 and day 2. I'm not saying like one's harder or easier, but there's more trig on day 1 than versus day 2 for sure. Conics show up next. So you're going to get the formulas like you did when you were originally tested. Conics, 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 more conics, conics, and then this new sequence stuff. So day 2 is a little bit of trig, lots of conics, and lots of the sequence stuff. Seniors, if you think you're in a position where you are going to have to take the sequence test, you might want to take it before you take the post test, just because that way if you're making a mistake, you don't make it again on the post test, because the post test is significantly more weighty in your grade. That's not a word, but it's going to make more of a difference in your grade because it's a final exam. Got me? All right, so everyone good with where the split is? I know it feels like it's not even, but it is even because the conics go a lot faster than they seem to go. Especially, like, remember the conic questions? Like, one question takes up 3/4 of the page. Like, they're really spread out.